Okay, so this is Mr. Wyrick. I'm here going over part 3 of the semester exam review. These are all in logarithmic form, which means the base to the other side is equal to this. That's 6 to the third equals 216. This one would be 2 to the 6th equals 64. This one, remember, is base 10. This one's base e. So that'd be e to the 0 power equals 1. On the other side, we're doing logarithmic. So you follow that same pattern. You just have to rewrite it in that pattern. That's log base 1/4, because that's my base with the exponent, of 1/64 is equal to 3, because it's this to that equals that. This would be log base 7,776 of 6 is equal to 1/5, because this to this power makes that. It's just a way of rewriting it. Just be careful on ones like this, because this would be the natural log of 1 is equal to 0. This would be log with no base, because it's base 10 of 10,000 is equal to 4. If you're expanding, the multiplication is addition, the division is subtraction. So this would be the log base 9 of 2 plus the log base 9 of x minus the log base 9 of z. One way that you can actually get this on the test, since it will be multiple choice on this, is to sub number values in for any of the variables, and then just check the answers to see if they come up to that same decimal equivalent. It's kind of like when we have the square roots. It's just kind of a workaround. Same thing with this on the condensing. These coefficients are exponents, so this would be log base 6 of u to the 6th, v to the 6th. This would be the log base 4 of 5, a to the 7th, all over b. Down here on the bottom, the solving, we did a lot of the solving. You divide this side by 5, divide this side by 5. So that would be 18 to the 6x equals 26 over 5. We would rewrite this as a logarithm. So it'd be log base 18 of 26 over 5 is equal to 6x. So this has a decimal number answer that they'll give you in the calculator, and then you just divide whatever that is by 6. Like, I don't really want to sit there and waste a whole bunch of time going through on this, but do remember, if this is a logarithmic, you will rewrite it as an exponent. But like, you can add the 7 first. That'd be 3 log base 3 of x is equal to 15. You can solve this one of two ways. Make it x to the third and then rewrite it, or you can just divide this side by 3, divide this side by 3. That'd be log base 3 of x is equal to 5. So 3 to the 5th is equal to x. And 3 to the 5th would be 243. So you'd have, again, you have a number answer there. That's probably what it'll be in the multiple choice. Just make sure that it makes sense, especially with the x's. You can sub numbers back in and see if it works out. On this one, the points of discontinuity is whatever is going to make the bottom into 0. So it's a -2, a -3 over 2, a +9. This one would be a 0, a 16, a -4. This one would be 7/3, 29, and 13. The other thing to look for is if they match top to bottom, like this 29 would be a whole. The 13, since it doesn't match, would be an asymptote. The 16, it's opposites. They don't match. This is going to be an asymptote. This would be a whole. This would be a whole. Actually, no, that one doesn't match. That would be an asymptote. On this one, when you're multiplying, it's just like we did before. So we factor. This would be x minus 8 and x plus 3. On the bottom, this is 2x times x plus 3. On the top, we have a 5x squared. And then since I already have an x minus 8, I'm going to put a -1 and x minus 8. Cross off the stuff that matches top to bottom. There's an x here and an x here. This is 5x over a -2. Okay? It's the same as like we were doing. With the division, we're going to flip it. So this is going to be t plus 7 and t plus 12. That's over 4 times t minus 1. And then this one we're going to flip. That's 2 times t minus 1. And this would be t plus 7 and t plus 2. The plus 7s go away, the minus 1s go away. 2 over 4 is going to reduce to 1/2. So this is going to be t plus 12 on the top and 2 times t plus 2 on the bottom. You leave it. Again, you can probably just graph this whole big mess and then graph the answers to check for accuracy because it's multiple choice. The adding and subtracting, again, we just did this. You find a common factor, so you got to look for the common factors. You got to multiply to get a common factor. This one would be x plus 2 and x minus 1, which means you multiply this side by x plus 2 over x plus 2, so you don't change the value. That's 7x plus 14. It's a plus. I go to combine like terms over here. That's going to be x squared plus 12x plus 7, which is not factorable, so it stays over x plus 2 and x minus 1. On this one, we haven't done this. We didn't do the solving rational, so I do want to kind of walk you through this one. I'll walk you through 37 because it's a little more complex. We need a common denominator over here on this side, basically. That means I have to multiply by x minus 1 here and x plus 1 here, but that's going to give me a common denominator for the whole thing. So that means I have 2x minus 2, and that's on the top, and it's subtracting x plus 1, and that's equal to a negative 2. And everything's the same on the bottom. Once I have everything the same on the bottom, I can ignore it. So this becomes 2x minus x, which is a single x, a negative 2 minus 1, which is minus 3, and that equals a negative 2. So if x minus 3 equals negative 2, I get a negative 1. The problem with that is that would leave 2 of these at undefined, so this would be an empty set. This would be a no solution. There's a lot of work that goes into doing this, so probably something that's going to be a lot quicker for you is graph this side of the equation, graph this side of the equation, and see where they cross. If they don't, there's no solution. If they do cross, you got the solution, and it's there on your graph. It's a whole lot faster. So that should take you through section 3.